Hello, my name is Andrew Grau, and this is my Physics 1 Lab 5. So the purpose of this lab was to compare the results of a simulated version of Felix's fall and the attempt to break the sound barrier with the actual experiment that was carried out in real life. So just comparing the simulation versus the actual experiment. So in this lab, I used GlowScript, Newton's second law, and the law of universal gravitation. And the main result, so the simulated output largely matched the expected values set forth by the real experiment, with just some minor differences. So, just getting into the main physics ideas and formulas. This is the law of universal gravitation formula, and then Newton's second law formula. So the experiment description. So this experiment is run entirely in GlowScript. So you can see the entire system, the Earth, and then Felix is the smaller dot there in the middle, and you can see his vector line there indicating how he fell. And then there's just some numbers there at the bottom that kind of describe the entire experiment simulation. And the assumptions for this was his mass was 118 kilograms, starting height was around 39,000 meters, the drag coefficient was around 1, and the acceleration was due only to gravity and the resisting drag. So the initial conditions there as well were 0, 39,000 meters, and 0. Then the initial velocity was also 0 because he started at rest before he jumped. So the GlowScript program model here. So the assumptions up there, you can see the gravity value, the mass of Earth, and then the radius of Earth, the mass of Felix, drag coefficient, the starting height. And then you can see the equations. So the equations for temperature and density, for gravity, and then the acceleration, velocity, and position update formulas over here. So this is the simulation output. So as you can see, as mentioned earlier, there's the big globe, which represents Earth, and then Felix is the smaller dot in the middle, and then you can see his line path indicating his direction. And then the results, so the fall time, 4 minutes and 55 seconds, peak speed, 820 miles per hour, peak Mach, 1.242, and he did break the sound barrier. So comparing this to the actual fall made by Felix, the results were actually very comparable. So he did actually break the sound barrier in the real experiment, and his peak Mach was around 1.2, and the altitude that he ended at was 0 kilometers, which obviously that makes sense. He had to go back to Earth, and the peak speed was around 820 miles per hour. So some sources of error in this lab particularly, though, I did not use a parachute in the model, and Felix obviously used a parachute to slow his acceleration and slow his final velocity so that he could safely land. And the drag coefficient also could be wrong, where I used a drag coefficient of 1. So moving into the what if and what does it mean? So what effect does a change in the density of air with altitude have on your predictions? So change in the density affects how he can move through the air, and it can resist his acceleration. So it can slow him down with denser air, and then with thinner air, he can obviously move quicker because there's less of a resistance. And then did Felix increase in temperature as he fell? So interestingly enough, as I looked into it, he did not personally increase in temperature very much at all, so it was quite negligible. His suit, however, did increase a lot because it started at, I believe, about negative 96 degrees Celsius, around there when he was up in space. And then it obviously warmed up as he reached the surface of Earth. But thank you. That was my Lab 5, and thank you for watching.